Hi, this session is on finding side lengths using trigonometry, and it covers questions from 3F and 3G, and I'll let you know what questions I want you to do from those chapters. Now, before we start, if you had the following triangle and I asked you to find what the length of x is, you would look at this and say, well, I can use it's a right angle triangle, so I could use Pythagoras. C squared is equal to a squared plus b squared. Okay, and we know that that's the hypotenuse, 6, so we have 6 squared equals, a can be x, so x squared plus 3 squared, and you can solve this to find the length of that side there. But what if you had a triangle that didn't have two lengths? To use Pythagoras, you have to have at least two lengths, so one here and one there, to find the other unknown length. Otherwise, there's not enough information and you can't actually work it out. But with trigonometry, we see triangles like this. So here's a triangle. Actually, I'll just draw it a bit better. Now I want you to draw this triangle up because you're going to actually solve it in a minute. But just have a look and see what information is given to us. So they're asking us, the question's asking us to find x. Find the length, this length, which we're calling x. Now, if we have a look, we've got a length here of 3 centimeters. We don't have a length here, but what is given to us, we see degrees. The angle here, between these two lines, the angle in here is 30 degrees, okay? And whenever you see this, it rings a bell that you have to now use trigonometry. We can't use Pythagoras because we don't have two side lengths. We have a side length, which is 3 centimeters, and we have an angle. So using these two bits of information, the 3 centimeters and the 30 degrees, we can find what x is. What is the length of x using trigonometry? To do that, our next step is to figure out which trigonometric ratio are we going to use. Now, if you remember from the last lesson, we had to remember this riddle, so katoa, and we use it to remember exactly what each trigonometric ratio is. Now, we know that S stands for sine, so this one here, just to recap, we have sine, whatever the angle is equal to opposite over hypotenuse. Ka, which is cosine, or cos for short, and the angle will be equal to adjacent over hypotenuse, and T for tan, or tangent, but tan for short, and the angle, depending on what the angle is opposite over adjacent. And we know with these trigonometric ratios, no matter what angle is given, just so we had the angle is 30, okay, so if we had sine 30, we did this on the last lesson, we got 0.5, sorry, it should be 30 there. So if the angle is just say 30 degrees with sine, your calculator will show you 0.5 or a half, and that is because no matter how big or small your triangle is, if the angle you're focusing on is 30 degrees and you're dividing the opposite and the hypotenuse, the lengths of those two sides, it will always give you 0.5. And you should have completed that activity sheet that helped you understand it a bit better. So now, to work out what x is, we have to use one of these, either sine, cosine, or tangent, okay? And we've got to work out which one do we have to use. So your next step is to label your triangle. Label all the sides. Hypotenuse is always opposite the right angle, so that's H for hypotenuse. And now the angle 30 is down here. What is the opposite of the angle 30? It happens to be x, okay? Oh, I don't know what happened there. I'll do it again. And that's the opposite. So O for opposite. I'll put P there as well. Now that means this length here is the adjacent. I'm not going to label the adjacent side because I don't need it. I'm focusing on O and H. Now out of these three trigonometric ratios, which one has O and H in it? Well, we can see it's the sine one. So this is the one we're going to be using, sine. So part of our working out is now, I want you to write down the formula that you'll be using. So we're using sine, okay? We can see the angle is 30, but before we put 30, just put the theta symbol because we're writing the formula out. Sine is equal to opposite divided by the hypotenuse. And now fill in what you have. So that's a formula. Now the angle is given to us. The angle is 30 degrees. So we've got sine 30 degrees Now remember, this is where students get confused. They see sine 30 and they think the sine is algebra and it's all confusing. Sine 30 is a number. What is sine 30? Sine 30 is 0.5. And we understand what that's telling us. It's saying no matter how big or small the triangle is, if you divide 3 centimeters and this length here, the opposite and the hypotenuse, it'll always give you 0.5 when the angle you're focusing on is 30. So sine 30, you know it's 0.5. So if you want to write a note, this here is just a number, and we happen to know it's 0.5. So I could have actually written 0.5 instead of sine 30, but I'll leave it as sine 30 for now. All right, and then we've got opposite. What's the opposite? It happens to be x over hypotenuse is 3. And now all we have to do is solve for x. I'll just make more room. Now, if you wanted to, you could do this. With the formula, you could have said the angle, theta, is 30. You have x is, opposite. We'll do it this way. O for opposite was x, and the hypotenuse h was 3. If it helps you to label it this way and then put it in, you can. So now we know sine 30 is 0.5. This, I'm going to emphasize it again. This here is a number, okay? It's not algebra because we've got the SIN. It is a number, okay? And our calculator will do it for us because sometimes we don't know what it is. We can have sine 45. We can have sine 2.1. We can't remember all of them. That's why a calculator, it's programmed in there. All right, so now we have to solve for x. If you want to rewrite it, you can write x over 3 on this side equals, yes, we know it's 0.5. I can write 0.5, but I'll keep it as sine 30. And our final step is to divide it by 3. We times by 3, cancels out, times by 3. And this is where you must have a calculator. I want you to put it in your calculator because you can make a mistake here. So I have x equals, now when I push sine 30 on my calculator, okay, this comes up. So I've got sine bracket 30. Now, if you don't close the bracket and you push times 3, what is going to happen? We're going to have sine, instead of sine 30, 30 times 3, okay, which is 90. Instead of sine 30, which is 0.5, and then times 3. So my point is, make sure on your calculator, you close the bracket and then times by 3. A lot of students make a mistake here and they can't work out what they've done wrong. So once again, we times by 3. So we push sine 30, which we know it will give us 0.5. So sine 30, but close those brackets. Then times by 3. And my calculator shows me 3 over 2 or 1.5. We'll write it as decimal, okay? And what is it telling us? It's telling us that the side length of x is 1.5 centimeters. So we can put centimeters in there. And that's it. So we found the length of x, not using Pythagoras now, but using trigonometry because an angle was given to us. Now for our second question, it tells us to find x to 2 decimal places. So it's really important that if it says 2 decimal places, your final answer is rounded off. Otherwise, you won't get full marks. All right, let's look at our triangle. So we've been given an angle and a side length. We haven't been given units. That's okay. We'll just write our value later on. Now, we can't use Pythagoras because we haven't got 2 side lengths. We have an angle and a side length. And we've got to find x. What is the length of this side here? Our first step is, what I usually do on my paper is write the formula somewhere on top, so I never forget this. So, toa, there we go. So I know which one's which. So now I'm going to work out which one do I actually use. So let's label my triangle. There's my angle here. So I can see the hypotenuse is this length here, but there's no information there, so I'm not going to label it. I have here it's opposite the angle, which is x. So x is the opposite. So O for opposite, or you can write the word opposite if you want to. And that means if that's the hypotenuse, I'll just put H just so we can see. That's hypotenuse. That means this length here is side by side the angle. That means adjacent. And we know adjacent means side by side with something. So I'm using adjacent and opposite. So O and A. Which one's got O and A? It is 10. So That's the trigonometric ratio I am using. So I'll write the formula out first. Tan, and the angle given, is equal to opposite divided by adjacent. Okay, that's why we've got O and then A first. Now that I've got my formula, I can see exactly which one's which. So tan, now the angle is, the angle is 42. So now I've got tan 42. And now that I've got that, tan 42 is just a number. You can have a head start and have a look at, see what it is on your calculator. Tan 42, I got 0.9, approximately 0.9, just to have an indicator. Is equal to, opposite is x over adjacent, which is 4. And now all I got to do is solve for x. Yes, you can rewrite it if you want to, but I won't do it this time. I'll just times it by 4. Now times this side by 4. You can put it on this end, or if you want to, you can go 4 times tan 42. If you do it this way, the brackets aren't that important. It's your choice. So 4 times tan, the angle is 42, is equal to, so x is equal to, I've got 2 decimal places, 3.6, okay, or 60, which is just rounded off. And that's it. The length of this side here, which is x, is 3.6, and we're done. We don't know what the measurements are, the units they're using. It could be centimeters or meters, but that's how easy it is. So this question is asking us the same thing. Find x rounded off to 2 decimal places. Have a go first, and then if you're not sure, watch this way. So I'm going to write my trigonometric ratios on top, so katoa, and now I will label my triangle. I've got opposite the right angle is my hypotenuse, there's h. Opposite this angle, which is going to be opposite, no, there's nothing there, so I can label it as O if you want to, but I'm not. I've got the adjacent here, where x is. So the information is focusing on hypotenuse and the adjacent. Which one has A and H in it? It is cosine. That's the one I'll be using. Okay, so just remember, to know which one you're using, it's where the information is. If I had the length of this side here, just say, you could use any one you wanted to, really, because you've got all the information on the triangle. But in this example, we don't have this length here. We're stuck using cosine. We've only got information on the hypotenuse, and we're trying to find x on the adjacent. So cosine and the angle given will be equal to adjacent divided by hypotenuse. I've got my formula. Now let's fill it in. The angle is 24 degrees, so cosine 24 is now a number. It's equal to adjacent, which is x, over hypotenuse, which is 10. And now all I got to do is solve for x, times by 10, it's gone, times by 10. I'll put times by 10 first, so I don't have to use brackets. So I just froze, so times this by 10. Okay, and now I'll have x is equal to 10, use a calculator, 10 times the cosine button, 24 is equal to 2 decimal places, 9.13. And that's it. We're not given, the 2 decimal places is 9.14. I hope you haven't forgotten how to round off. So it should be 9.14 to 2 decimal places. We haven't been given a length in terms of which units, so we just stop there. And that's how easy it is. The next few questions we're doing, we'll be doing the exact same thing, but it's just a bit trickier because we end up with x on the bottom. Okay, so this solving for the denominator comes from exercise 3G. So I'm doing some questions from 3G. The previous ones were from 3F, and I'll let you know what questions I want you to do as well later on. Now, if you have a look at this equation, if I asked you to solve this, the long way would be to go, to make x on top, what I can do is times this side by x, cancels out. I must times this side by x. Then I end up with 2x equals 5. Then divide by 2, and x will equal 5 over 2, or you turn it into a mixed fraction. Now, you can always do it that way if you want to. That's fine. If it makes sense to you, then go ahead. But you have to make sure you know some way on how to get this x to put it on top. Now, we have done questions like this in the past, but you may have forgotten. Now, the other way of doing it I'll just write it out again. 2 equals 5 over x is to simply switch. I didn't draw it properly, so I'll just fix the 2 up. And what I mean is, see that 2, how it's sitting on an invisible 1? What you do is you switch the x and the 2. So if I just switch them, I'll end up with this. X over 1, but the 1 can be visible, equals 5 over 2. Now that was much faster than doing it this way, but it is your choice. So you've got method 1 or you've got method 2. I'm going to use method 2, just switch the x and the number on top. And with trigonometry, this number is usually on an invisible 1. So just keep that in mind, okay? And that's it. Or do it the long way, times by x, both sides, then divide by 2. Both will give you the same answer. You choose which way you want to do it. All right, so once again, for this question here, it's asking us to find in this case y, or the unknown variable, to 2 decimal places. Usually it's always to 2 decimal places, but always be careful and read the question. So our first step is what I do on my page, so katoa, so I don't forget. And now I'll label what's given to me. I can see I've got the hypotenuse opposite the right angle, so that's h. Opposite 35, there is a 5 there, so that's my opposite. So I've got opposite and hypotenuse. So O and H. Which one has O and H? It's sine. So I've got sine, and the angle given is equal to opposite divided by hypotenuse. First write the formula out, and now let's fill in what we have. All right, my angle is 35 degrees. That's easy. So I've got sine 35 degrees. We know this is just a number now. Is equal to opposite is 5 and h is y. We can see how we've got the y in the bottom, okay? Now remember, sine 35 is just a number. The reason why, if I push sine 35 on my calculator, it gives me an infinite decimal. And the reason why I'm not going to round it off, okay, is because my answer won't be as accurate. We know as soon as we round off a number, our answer is not going to be accurate. So if you're doing this, if you go sine 30, for example, and round it off to 2 decimal places 57 equals, and you try and work it out this way, yes, your answer will be close to the correct answer, but it won't be accurate. So never ever round off, please. Don't go sine 35 and then have a number. You have to get used to seeing sine and cosine and tangent and so on like this, okay? So this here, sine 35 is just a number. So now what I'm going to do is to switch. So the fast way is, I know that number, sine 35, is over 1. So I'm going to switch the y on the bottom with the 1 on top. If you want to do it the long way, you can. Times by y, then divide by sine 35. But this is the best way to do it. So switch it. So I will have now y is equal to 5 over sine 35, which is just a number. You can put it in brackets if you want to, if it makes more sense. And now your calculator will do the work. So I've got 5 divided by sine 35, and it gives me 2 decimal places 8.72. Sorry, that's a 7 and a 2. And we're done. Oops, sorry, that's it. It's a 7 and a 2. So with this one, it's only different because the variable ends up on the bottom. When that happens, all you got to do is switch it with the 1 on the top on the other side. Or do it the long way, your choice.